handing over to Rob. Rob is a last-minute replacement because Alex has, unfortunately, an emergency issue he needs to deal with. So we've brought Rob's presentation from all the way at the end of day 2 into this slot. So Rob, thank you so much for joining us. Rob has been a TAD Summit, TAD Hack regular, really from the beginning. In fact, it was the beginning. Oh, how could I forget? You were there at TAD Hack in Madrid.
I was, yeah. I think there may even be an image of my slide somewhere because you've got to keep using that one. So we'll keep that one dry. But to be honest, I think you're very, very lucky to be seeing me at 2:30 in the afternoon here in the UK than at 8:30 in the evening. It's probably going to be a more pleasant experience for everyone else. I can cope, but I'm not so sure. Yeah, so Alan, what I'm going to talk about today is some of the recent work I've been doing with using speech-to-speech AI models to build natural-sounding, accurate agents. Let's dig into that, shall we?
Absolutely.
Okay, so really, really briefly, my own background in conversational AI, and there, right down in the bottom corner, is the obligatory TAD Hack picture of Google beating me over the head with a check. But my own background is in stuff that's nothing to do with AI. So building telecoms infrastructure as a software engineer, as a company founder, as a whole bunch of other stuff. So I didn't really discover and get involved with voice AI until kind of the 2019 point, where I started building voice AI around natural language understanding type agents. And there's a whole bunch of stuff around that. Won't bore you with that. You can go back to TAD Summit 2021 for a write-up of that stuff. But fundamentally, produced a bunch of stuff that didn't do fantastically because of the long time to onboard people, particularly in SME space. So I kind of bounced off voice AI in 2020, 21-ish. And then 2022 came back to it when GPT-2 released. Because I kind of looked at all the stuff we've been doing with natural language understanding and the sort of API.ai, Dialogflow type technologies as they were then, and then looked at what OpenAI were doing with GPT-3 and 3.5 and got involved in building audio agents again. So I started gluing together transcription engines, speech to text into pipelines with large language models, and converting that text back into audio again. So we kind of built this thing in very early 2023 based on OpenAI, and then extended it with 14 other models. It was based at the time and still is on Jambones. I think you have Dave on later today to talk about that particular product, which is an absolutely fantastic open source CPaaS. And that was the obvious thing to build on back middle of last year, because it had a great framework for doing speech to text, another great framework for doing text to speech and moving things around, and very easy to bring SIP minutes into it. So that's kind of how we built this thing. And the idea was really to have one infrastructure that allowed us to go and prototype really quickly a whole bunch of products in this space, interacting with back-end business APIs. And the fundamental architecture, this is the same architecture everyone who gives a presentation on, or everyone who gave a presentation on voice AI up until kind of July, August this year, it would look like this. Basically, you've got some media ingress, typically use some kind of media agent for that, free switch, which of course Jambones is kind of based on for that part of the activity, Asterisk, WebRTC, LiveKit membrane, into a speech to text engine, convert it into some text, and then talk to a text mode large language model. So these things were designed for people typing stuff in text chat, but we were kind of perverting that by sticking text into them, getting the text back out, putting that into a text to speech engine, and then handing it back to whoever we were talking to, the human we were talking to, through the media stream. Kind of uniquely, the way that we decided to do it was because of wanting to quickly prototype using different models, not wanting to spell the whole world GPT. We built this kind of infrastructure with a single JSON description file that represented an AI, but you could then use that with any of the then available models through any of the speech to text and text to speech. So it was quite neat and quite a useful way of doing it. I think someone else also kind of the SignalWire folks have a very similar thing where you specify the agent once in a description file, and that allows you to then port it around and use it. But that gave us something to start working with. Whole bunch of issues that we discovered and walked through as we built that. I'm not going to go through these in detail. I think these were part of a much larger kind of half-hour techie grade presentation, but they were around things like term prediction and latency and interruptions and controlling the conversation. Because of the way that we're really we're taking text mode large language models and we're gluing the voice onto the side of it, so they're not kind of designed to operate this way, and it surfaces all sorts of issues with latency and not handling interruptions very well. And then the very last part is this kind of controlling the conversation, making sure the AI doesn't, threaten to burn your customers' houses down or something, or generally coming up with weird hallucinations where it tells Chrysler customers to go and buy a Tesla. Or there are very famous examples of, and we went through various
definition.
Our first
sorry,
mechanism.
Rob, just trying to interrupt you here. Turn prediction is turn of conversation. I mean, we know it, but it's not widely known in the industry. So just mention, understanding that the customer or the other party has finished what they're saying and is now the time to interject, rather than they made a slight pause because they were like trying to think what to say, and then the AI interrupts them.
Spot on. I absolutely should have done the longer version of this presentation when I kind of explained that. But what I actually wanted to get on to was some of the kind of the sexy videos and demos of the
exactly. No. I just wanted to
demonstrate how far we've kind of gone beyond those kind of problems. But by about June of this year, based on all of those tweaks and algorithmic optimizations and things, we'd got something which was pretty good, actually. You could fake a fairly natural kind of conversation. And I have this demo that I like to do of the kind of the pinnacle of that pipeline approach. I really love EMF Camp is a UK hacker camp. They base their phone network. They have hundreds of phones there, loads of people like me sitting in a field messing with stuff, loads of phones around the place, but they actually use Jambones as the backbone of their phone network this year. So we built something basically for that. And I love this as a demo in this kind of presentation, because all of the back end data for their talks and villages and things is kind of available, and it's totally not commercial, so I can demo it and there are no commercial confidences and I'm not giving away anyone's business model. So forgive the very kind of I would say interesting application, but it is super interesting. And as I say, by the time we got to about June this year, when we went and plopped the architecture on the network, talking to their Jambones instance, we got something that worked quite well. And I'll just show you a kind of like a little bit of that sort of working now. So this is our playground, which is a sort of a graphical GUI for developing these things. We prompt it. There are a bunch of downloadable prompts, and we use function calls. So there are some function calls here that go talk to the EMF backend, and we'll just start an agent on a phone number, pick a voice for it, and then call into it. You getting the audio okay now?
No. Can you turn it up? Just about. Might need.
Just a moment. Water, village, which is big on LED
there you go.
Digital radio. Also, don't miss the talk when a tree falls in the forest. Does it cause a fire?
Okay, that sounds reasonably boring. Have you got anything shocking?
Okay. How about the musical Tesla coil demo on June 1st at 21:30? It's a shocking performance with Tesla coils and electronic music. That should electrify your experience.
Yeah, okay, that does sound like fun. But I could do with some coffee and cake now. Where can I get that?
Okay. Let me brew up some info on coffee and take spots for you. Hold tight. For a caffeine and take fix, head over to Industries for a chat.
Okay, so you can kind of see there, it's not halting anymore. If people saw some of the early demos we did with this stuff, kind of running about June the year before, we've got those 1-2 second delays and things like that going on while all of that API querying and things is in place. But a lot of that was actually done by cheating. I call it cheating as a technologist. It's called optimization by salespeople. But what we're effectively doing is, so the okay at the end of each bit wasn't actually coming from the AI. We had a set of canned response phrases where effectively that would just be squirted straight out of the text to speech immediately the user turn had finished, to kind of give the impression that we were listening. And then there was a bit of logic in the prompting that said, while you're going and doing the API fetch, make a humorous comment and all of that stuff.
Yeah.
But, it was pretty good. It was, certainly there are products based on this kind of technology, and it kind of works well enough. And then, that's where we sort of were in June. And then this happened. So I don't know if folks remember the OpenAI spring update, seems like forever ago, where they basically sort of demoed this thing with really natural sounding speech, where they were effectively doing speech tokenization straight into the AI. And I kind of predicted for a while this might happen. I was surprised how quickly they did it, but then it actually turned out they didn't really do it that quickly because they demoed it and it was a long time before it became available. I'm going to come to the reasons for that in a little while, but that certainly, kind of got us thinking, developing, and sort of chomping at the bit to develop. But of course, that didn't come out in the API until a couple of weeks ago. But certainly those multimedia models had arrived, even if they weren't available to independent developers. And actually, the first speech-to-speech model that landed was from a company called Fixie.ai. People who work in this space may remember some of their founders who were at Google behind Google Meet, and some of the IETF work on WebRTC. So quite a serious company doing some work in this space. They developed a model called Ultravox. The interesting thing about it is that all the moving parts are open source. So it is a speech to speech model. All the parts are moving source. You can download it, train it. It can be run on some of the runners like VLLM, and it tokenizes audio chunks directly into the conversation mixed with text. Right at the end of August, they developed a LiveKit-based SDK and API as a hosted service. So we thought we're going to have to go and have a go with that and see if that fixes some of these problems. So let's have a look at the results of having a go with that. Same agent, same prompt, same lame things that I'm saying to it. So we integrated it into the playground, and this time we choose Ultravox 70B. This model talks directly via WebRTC rather than through a phone conversation. So we'll give that a run and see what happens.
Hello, you're through to EMF RoboHelp. We want to make sure you have an amazing time at EMF Camp, and we're here to help with any questions or info you need. What's on your mind?
I'm really interested in talks about fire, if you have anything like that.
I've just searched the schedule for talks about fire. There's a talk about preventing wildfires, another about decorating eggs that involves burning wax, and a few others that mention fire or flames. I've also found a village that has a Tesla coil demo that involves fire. Would you like more information about any of these?
Yeah, the thing about preventing wildfires sounds interesting. Tell me more about that. When is it on?
The talk about preventing wildfires is on Friday at 7:30 p.m. at Stage B. It's called When a Tree Falls in the Forest. Does it cause a fire? And it's about using satellite imagery and machine learning to understand individual trees and prevent wildfire.
Another AI thing. Okay, tell me more about the Tesla coil thing.
The Tesla coil demo is on Saturday at 9:30 p.m. at Odin's Tesla Fest. It's a musical demo with DJ Odin, Extreme Electron.
Okay, so, we can see that is substantially better, right? So we're getting an almost immediate response in a natural way to those conversation pieces without any need for those holding phrases. Now, because it's only using Llama 70B as a model, Some of the logic around, some of the prompted logic around putting the holding phrases in while it's doing the API call weren't being picked up in that. So effectively, we do get those slight delays while it makes the API call. But you can see the way that you can start to optimize that, and that certainly gave me some sort of food for thought in terms of, can we actually start picking up on these speech-to-speech models and using them in anger? And that happened end of September. Actually, we developed and put it into the web user interface, and I demoed it at a talk in Poland in mid-September, so about a month ago.
Yeah.
And then, right at the start of August, this is a bit of a thread with AI, that roughly every 2 weeks something revolutionary happens. OpenAI finally made available their real-time API, which is a thing that was speech-to-speech, that they demoed back in sort of May, June time. Now, it's actually rather hard to use directly because it's WebSocket based. So you've got to be pretty deep into development to want to use them that way. But they did some third-party integrations with LiveKit that put a wrapper around it to make it usable for a WebRTC session. There are various technical reasons why you really don't want a WebSocket-based interface, and that probably isn't where this is going to end from an OpenAI point of view. But again, we did the integration with that, and that took 3 or 4 days, and same prompt, same web interface, up and running with OpenAI. So let's try exactly the same prompt with GPT-4o.
How can I help you today?
I'm interested in fire.
Fire, the primal element. Let me spark. I found some blazing hot events for you. There's a talk on when a tree falls in the forest, does it cause a fire? By Laura James, and a fiery musical Tesla coil demo at Odin's Tesla Fest.
Tell me more about the tree falling in a forest thing.
Sure, it's a talk titled When a Tree Falls in the Forest, Does It Cause a Fire? By Laura James. It covers how Overstory uses satellite imagery and machine learning to understand trees, with a focus on preventing wildfires and power outages. It's happening on May 5th, from 19:30 to 20 minutes at Stage B.
Okay, that's cool. You said something about a Tesla coil as well. What's that about?
Yes, there's a...
Okay, so again, we can see really natural conversation integrated with our own data. Interruptions work well. What's the catch? Well, the catch for OpenAI at this point with the real-time model is that it's breathtakingly expensive. So $100 a million tokens for input, $200 a million tokens for output, which translates to about 6 cents a minute while it's listening to you and about 24 cents a minute while it's talking to you. So that's kind of, human agent level of cost. Yeah. There are going to be very few applications that are going to unlock an AI benefit at those kind of costs. But I think I'm actually happy to predict that this is actually a holding pattern. OpenAI are trying to do something here at scale. The Ultravox guys are kind of doing it, and they've got some real serious WebRTC expertise that they understand how to do that with. OpenAI coming at this. Up to now, their entire kind of problem space has been around running these tiny little stateless AI jobs, where the API takes a textual or a multimedia input and it just gets farmed out to any spare GPU anywhere in the world in a completely stateless way, sends the results back. In order to start building infrastructure to do this at scale, they've got to own this whole problem and grok all of this audio coming in. And they've got to grok it into places in the network that are relatively stateful. So load balancing that around and finding that close to GPUs and things is going to be quite hard at scale. And to give you an idea of the kind of problem they face, several months ago, I looked and they had 180 million users, 100 million active users. Even if those people are only spending 2 hours a month talking or listening to an agent, that's 200 million hours of WebRTC data. Those guys have got a grok, and I'm quite certain they'll be building infrastructure to do that. But that isn't going to be cheap. And right now, I suspect they're pricing to suppress demand. But that shouldn't stop us building for it. Which approach owns the future? Speech to speech is the generalist technique. All the stuff we're doing with term prediction, voice activity detection, we're doing algorithms. There's this fantastic letter called The Bitter Lesson by Rich Sutton, who basically says every time we've done anything with AI, we tweak stuff programmatically with algorithms, and then we give up, and we effectively just put the data into a suitably trained model, and the results are 1,000 times better. And that's my take on speech to speech, and why it's probably going to win out once the cost becomes reasonable. It can also understand the full bandwidth of speech, so we haven't got this thing where we're converting the speech into text, and that's lacking all inference, where the same word means different things depending on the context.
Yeah.
Quick note on how we were able to build those demos so quickly. So in May 2024, we had this, where we effectively had our agent definition, Jambones, all of the different text modes APIs behind it, and effectively, in order to accommodate Ultravox, we bolted Ultravox onto the side. Because the agent definition and all of the stuff to do the function calling was standardized, that was a really quick job. I think it took about a day to do, which was great. And then OpenAI real-time came along, and to kind of leverage that, that's based on LiveKit agents with worker processors. So then we bolted something else on the side. And okay, it all lives behind the API, so we sanitize that away. But this thing is starting to look, once you get to the point where you're crossing lines over on a diagram, it's getting a bit serious. There's a bit too much complexity there. And I think, we kind of stretch the architecture beyond its elastic modulus. It's now a bit of a broken string, or broken spring even. So we're now working on resetting the architecture to an entirely different model, where instead of designing for the instrumented case, we're designing for a case where we can accommodate all of the different worker processes, and then layer the observability on the top. Now, that means we're not going to lose any of the interoperability. We're still going to have all of that. The API is going to be largely compatible, but we have to do a couple of things to decouple the agent from the instance of the listening agent. So we grow a couple of calls. So we now create an agent and then create a listener, and the listener goes to the appropriate worker. But it just very much resets the architecture to something which is designed for scale and running the applications, and then we're layering observability on. And we've lost a couple of things in the API around doing direct injects into calls.
Yeah.
You want to go and play with any of this stuff, it's sitting on Applicet's GitHub. There's a little playground on llm.applicet.com, so you can directly use it. And within a week or so, the new API will be sitting there, as I say, with a couple of tiny breaking changes that just make the thing entirely more scalable and take into account some of these new speech-to-speech development. So, in quick summary, just to leave a little bit of time for questions, text-based pipeline cascade approaches exist that can be made to work with lots of tweaking and optimization, and that's great because it means that we can produce stuff that works. Lots of people have invested lots and lots of time and money on this. I mean, I can't understate how many voice startups there are and voice systems there are that have invested in building pipelines since the same time frame we were doing it, 2023 onwards. And one of the interesting properties, and I'm sure Dave will say much more about this later when he talks about Jambones, is that there are some unique control points that are important, particularly for critical contractual and regulatory reasons. So one of the problems with speech-to-speech models is that in general, you don't get to hear what the AI says until it says it. You haven't got that speech control point where you can look, or you can even, kind of filter the AI down to only use certain canned responses. So I think there are still going to be niches and still going to be important areas, and indeed from a cost point of view, speech-to-text model, text-to-speech pipelines are still going to be important. But I think it's highly likely that multimedia approaches are going to win out. It's clear there's going to be a much better experience, both from kind of the amount of information and context that the model can get to more accurately respond to the user utterance, but also in the kind of the speed of the response as well. So, to me, it's a no-brainer that the natural conversations are going to be the speech-to-speech models. I think it's always going to be a little bit more expensive, but I think that gap is going to reduce as the AI providers figure out how to build this at scale.
Over what timeline do you think we'll see that price drop? Because at the moment, I mean, it's a massive price difference.
Yeah, I mean, it is. It's a massive price difference, but I mean, Ultravox are at 6 cents a minute for the whole session, so that's
Okay.
a factor of over two difference.
Yeah.
And the nice thing about Ultravox is if you want to run their model, it's open source. So they won't give you the SDK and all the bits around the edge to make it work, but they will give you the model. You can go and train it on, it works with any open source model with open weight. So you can train it on Llama, you can train it on Mixtral, and you can train it on any of the Chinese models. So, thankfully, and I'm really, really pleased, and that brings me neatly on to the next point, actually, that because of this chance of market capture, the fact that we have got these open source alternatives out there, and it is open research rather than open AI closed research, is kind of a really good thing. So I'm going to keep building agnostic architectures for this stuff.
Excellent.
And that's really the summary of the whole thing. Speech to speech is breathtaking. It's also breathtakingly expensive, but it probably is the future.
So where do you see I mean, a lot of the cases are just basically replacing agents. But with speech to speech, what are some of the other interesting applications do you think are going to come out?
I mean, they're all replacing human beings and the intuition that human beings have, right?
Yeah.
So in a way, they're all replacing humans with agency, with AIs with, this is controversial, with agency.
Yeah.
But I think a lot of the non-visual, the non-verbal cues, or the non-linguistic cues in speech. So, a lot of the stuff around insurance incident reporting, where people are doing non-real-time analysis on fraud detection and things like that, suddenly become, because the way someone says something can tokenize to, they crashed into me, yes, they really did, or they crashed into me, gosh, if I say this, I might get away with it. Tokens don't work like that, but you get the point. But I think, there is another piece that video is hot on the heels of this stuff. So we'll make this cheap enough to use, and then video will come along breathtakingly expensive, and then we'll make that cheap enough to use. So the whole idea of, I would like to think that certainly when we've got video agents, then the whole piece about helping people with hearing difficulties online. So we suddenly get agents that can do sign language, for example, rather than resorting to mini-coms and all of that stuff. That I would like to think that when we start doing video and these breathtakingly expensive things from an electricity and audio point of view, that we will actually use them to deliver kind of socially transformational applications, rather than just more convincing salespeople who will pop up in videos on Facebook and try and sell us stuff we didn't need, right?
Exactly. No, because at TADHack over the weekend, VCon, I think, hit a stride with a lot of the developers. They were using it in ways that had nothing to do with, boring voice-related use cases, with sort of, enterprise comms. I mean, there was like, what was it? The shrine at the Temple of Computing was one of the hacks. And it was using VCon, it was using the features of VCon, but it was all about this, shrine in the Temple of Computing. And you had this NFT tag, you put it in the repository, and then, there was some, an experience was had, and then wherever you went afterwards, you could take that, token, and you could relive the experience, which, it's weird and wacky, but that's when you say, oh, this tech is like, people are using it now in quite interesting ways. So that's why I was asking around, with speech to speech, how you think this will progress beyond, the usual, sort of customer support or customer care applications.
Yeah, it's kind of interesting. I've done a shift since I started developing this. So I started developing with it, obviously, start of last year. And my feel then, and I guess this is because I'm a telecoms guy, I guess in some ways coming from a telecoms background, my first instinct was to glue it onto a phone call and do SIP. And I think, voice calls with AIs are probably going the same way as voice calls with people. And the way this is going to appear is as WebRTC, the kind of the AI version of contextual communications, where I think 95% of it isn't going to be on audio only phone calls. It's going to be in WebRTC sessions.
Yeah, exactly. No, that's excellent point. Again, Rob, this was perfect. thank you so much for sharing this insight, sharing your experiences with the models. That was really fun.
Pleasure being here, Alan. Thanks for giving me time to talk to you.
And also thanks for stepping in at the last minute. So that was great.
No